Open Application Model with Sudhanva Huruli.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your humble host. Make sure to check out www.azuredevops.show, the podcast website, for the past episodes and show notes. And we have just tons of great past episodes. And we're going into the end of 2019 now. In January, I'm teaching another class of my .NET DevOps Bootcamp. Sign up now to reserve your spot. It's going to be a great, immersive, hands-on class here in the Austin, Texas area. So with me today is Sudhanva Huruli. He's a maintainer on the Open Application Model, and he's been at Microsoft for over 2 years working on the distributed systems platform, including Service Fabric and Kubernetes and other things. And I'm really excited to talk with you today. And thanks for being on the show, Sudhanva. How are you doing?
Oh, I'm doing fantastic. Thanks for the introduction, Jeffrey.
Well, there's a lot of great work that we need to dive into, but would you mind give us just some background on your work and how you landed at Microsoft, what your journey has been kind of up to this point?
Yeah, absolutely. So I actually interned at Microsoft back in 2016 on the core compute team. And after my internship, I signed on full-time and I started working on Service Fabric, which is our distributed systems platform that powers the majority of Azure, Microsoft, and also a lot of external companies. And then once I started working on Service Fabric, I transitioned to working on Service Fabric Mesh. If you remember, it was a preview service that we released, which was really targeted towards abstracting away the infrastructure. And then we took what we had with Mesh and we turned it into the open app model, which is what we're here to discuss today.
Awesome. And, you know, we had a recent previous show on Dapr, DAPR, which I think is also comes from the distributed systems platform, if I'm not incorrect.
Yeah, so the inspirations of both Dapr and the open app model both come from the Service Fabric ecosystem. So Dapr kind of comes from the actor-based model that we had, and the open app model comes from the Service Fabric Mesh side of things. But really, both of these projects, we took our knowledge that we had with these internal systems, and then we wanted to make sure that the open source ecosystem would benefit as well.
So this distributed systems platform, help us understand, that's kind of an umbrella. How is it organized where, well, you know, OAM kind of a part of it, but how do y'all think about that architecturally?
Yeah, so the way we look at OAM is when developers are describing their application, today the options include, things like Service Fabric or Kubernetes. They're exposed to a ton of infrastructure. So what we wanted to do with OAM was create a platform agnostic model which allows developers to describe their apps without having to think about infrastructure concepts. That was kind of the core of the thinking. That was a core premise of SF Mesh as well, which was I can deploy apps to the cloud without needing to manage an orchestrator or manage infrastructure. So that's kind of the thinking behind OAM. And architecturally speaking, it's really just an app model. It's just a spec.
Okay. All right. So now we've used the term a few times, open application model, but our listeners don't know what the heck that is yet. So
right.
How do you define it? What's the best kind of layman's definition?
So the best single sentence that we use to describe it is it's supposed to be a team-centric standard for building cloud-native apps. So if you're a team that's looking for a way to describe your application to deploy to the cloud, the open application model offers a specification that you can follow to describe the app. That's simply put, that's what it is. It's open sourced. We collaborated on the specification with Alibaba, actually, and it's a partnership right now. Okay.
So if I'm coming from if I put my .NET developer hat on,
yeah,
how I'm used to describing my app is, hey, I've got a ASP.NET project. I've got a backend job I'm deploying to an Azure function, and I've got a SQL database. Boom, there, I've described my app. So how is it different now if I'm describing my app, or help me out here.
Yeah, so the open app model is different than functions or app service that the .NET developers might be familiar with, because in those are truly serverless models. So you go from code straight to deployment. Now, if you're looking at more complex applications, where you have a dedicated developer team, an application operations team, and an infrastructure operations team, who is responsible for managing, on-premise infrastructure that you're deploying your .NET apps on, you still need a way to take your .NET apps and actually deploy it on that infrastructure. And part of the deployment might be, not just your .NET app, it might be, as you said, the SQL database. So for those situations, we thought it would be great for the development and the application operations team to have a single spec that they can describe their application on, and it can be deployed on-premise and also in the cloud. So, for example, like you don't have app service on-prem, you don't have functions on-prem, and as good as functions and app services are, if you're deploying really complex microservices that have dependencies on each other, those aren't the best platforms in Azure for you. You might, turn to something like Kubernetes or Service Fabric for that. And when it comes to deploying apps on that, it's very infrastructure heavy. So we wanted to create this common spec that you can use to describe your app and deploy on any infrastructure anywhere.
Okay. So this is a solution always born from some pain. You mentioned that it was a partnership with Alibaba, which is a really, really big company. What were the symptoms, or how is that pain being felt where y'all said, okay, we need a solution. We're not the only ones who struggle with this pain. Let's come up with a solution. But how is it being manifested? What was the challenge that became the genesis of this?
Yeah, so there's two big ones. The first set of customers that we talked to, and the common theme is that these are generally all large enterprises, which have, as I mentioned, these dedicated teams for development and operations. And generally, when we spoke to the operations teams, they would say, hey, when we onboard a new developer and we try to describe, or we try to tell them how to deploy apps and get themselves running, there's a lot of docs to read. And if they're deploying it on some of the standards out there today directly on our infrastructure directly, they have to read a ton of docs just to be able to deploy an app and get onboarded. So they wanted to have something that the developers could use that was easier to deploy applications. That was kind of the first set of customers. The second set were, when we talked to the developers directly. And the developers would often say, hey, I just want to, focus on my code. I just want to write code that offers, features and adds to the business logic. And I'm spending a lot of time figuring out the plumbing of these infrastructure systems in order to just deliver what I'm, tasked to do. So we wanted to solve kind of both of those problems. As we talk to more and more customers, that's what we're finding is the former, which is, get these developers onboarded really quickly, is creeping up. And kind of the third big one is a trend that we're seeing is more and more deployments are happening on the edge, whether it's on-premise or even tiny edge devices. And we wanted to get ahead of the game there and make sure that the spec that we're defining can be used for deployments on any environment, whether it's the cloud, on-prem, or even tiny edge devices.
Okay. And you've said spec multiple times. So should we, is this one of the watch and see and it's coming in the future, or is it ready to be used in any form right now?
Yeah. So, I've said both, open app model and the word spec a couple of times. So let me just kind of give a taxonomy of what these things mean as far as this project goes. So the open app model is kind of an umbrella term that I'm using, and it refers to the whole project as a whole. So the project has the specification which we've released. It's in alpha, so it's just in the first release. And with this first release, what we've stated is that you can go ahead and build implementations on it. So I introduced another term, which is implementations. So the specification is just that. It's just a spec. It just kind of gives you standards on how to describe your apps. But then you actually need an implementation that's going to take this spec and do stuff with it.
So the spec it's on GitHub, is that right?
It is. So if you go to openappmodel.io, there are links there that take you right to the spec repo.
Okay. And the spec, is that in format of markdown files? Any C sharp?
Yeah.
How's it? Okay. Just docs.
It's just markdown files. One of the other specs that Microsoft has released recently is the CNAB spec, the Cloud Native Application Bundle spec, and it follows kind of the same format as far as specs go as that.
Okay. Awesome. All right. So how do people create implementations? How does that go? And what implementations are out there so far?
Yeah. So the first implementation that we created was in Rust, and it is on Kubernetes. And we are actually partnering with a couple folks right now to create implementations not only on Kubernetes, but also looking at a Terraform provider for this thing, so that you can truly deploy this anywhere. And we're also working with a couple of startups in the CNCF to actually build other implementations of it. The best way to get CNCF is the Cloud Native Computing Foundation.
Awesome. Okay.
It's under the Linux Foundation umbrella, houses a whole bunch of cloud native projects, including but not limited to Kubernetes, Helm, and other things. But one of the other teams that are actually working on implementations is, of course, Alibaba themselves, who are looking at taking the specification and deploying it to their services that they offer. So in the Kubernetes implementation that we released, you still manage the cluster. You're still managing the Kubernetes cluster. But it would be nice if one of the cloud providers offered some sort of implementation on their cloud, which just took the spec and ran it for you without
like
you needing
Azure?
to do it. Yeah, exactly.
So what are the plans there?
Yeah, so we're looking at options there. Obviously, within Azure, we have Service Fabric Mesh, which is a previous service today, and we're looking at how we can evolve that. And we're hoping that the spec kind of plays a part in there, but we're still in the forming stages of that, and we're looking at how we can take the spec forward on Azure.
Okay. Now, some of the listeners and myself as well is thinking, okay, well, what's in the spec? What are the concepts? And even if there's no .NET implementation literally today, it's still being worked on, or no Azure implementation today, you guys have tackled a hard problem that is pretty common. When you have dozens and dozens of services and web applications and databases running all over the place, and then they have dependencies on one another, this mesh or graph or tree, however it ends up being, that's a big challenge to continually deploy and rev and test the combination of applications that work together. So what are the, is there a cliff notes of the spec that you could give us that people might just help them understand the problem that they might be working with today?
Yeah, so the specification itself has 3, maybe 4 major parts to it. And really, we broke it down based on what we got from customer development. So we talked to a ton of customers, both big and small. And let me tell you, one of the things we were looking for is, how do customers define their apps? Because if we're going to create an application model, we were like, we need to create some sort of application standard. And right away, the theme that we found was every single company, every single team has a different definition for an app. So some teams, a microservice is their app. Some teams, their entire business is their application. Others have databases. So the first kind of construct that we introduced was this thing called a scope. So scope allows you to take a bunch of microservices and wrap them around in a scope that makes sense for your org. So an example, if I have 2 to 3 microservices and they all need to discover each other, then they can be put in something called a network scope, which allows these services to be discoverable by other ones. We also have a health scope, which means that during an upgrade, if one of the microservices fails, then the overall health scope is going to report an error. And you can take these microservices and put them in scopes that are independent of other scopes. So it allows you to kind of form your own applications. That was really the goal behind the scopes construct. The second one is, and this is one that's really targeted towards the developer, is something called a component. So when you're creating your microservice, all the component spec has is it allows you to describe how your code in that service is supposed to run. So whether it's supposed to have a single instance, whether it can be overridden and have multiple replicas. And then there's a description of the code that's actually running. So currently what we support is containers, but we're leaving that open, and we're saying that you can also run things not in containers. So like a function could be a type of process that you're running.
Mm-hmm.
And then the last bit is something called traits, which allows you to take these components and add operational characteristics to it. So I can take a component that was written by a dev and say, hey, I want to add an ingress trait so I can expose this to the public internet. I want to add an autoscaler trait and scale it based on these metrics. So those are kind of the three big parts. The component is really targeted towards the developer, and then the latter two is really for the application operator to kind of create how they want these components to run in production with the scopes that they want.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
Let's get through some announcements. The .NET DevOps Bootcamp training course, another date was announced for the course. We had a fantastic class in October, and next class will be January 16th and 17th in Austin, Texas. And this class is based on my latest book published through A Press, which you've heard about, .NET DevOps for Azure. And if you'd like to learn more about how to set up that high throughput DevOps environment for your team, get the copy of the book, .NET DevOps for Azure, anywhere tech books are sold. Also, as many of you know, I'm available for hire. I love helping teams get better. And one of our very popular services is a 30-point DevOps inspection covering everything from your version control structure through builds, testing, quality control steps, to deployments, and even production monitoring. And between now and Christmas, we are giving away a few of these for free. Now, the price for this is $5,000, and we provide a comprehensive report with concrete recommendations and a plan for resolving any gaps we see. So send me an email at jeffrey@clear-measure.com. That's JEFFREY. And once the promotion schedule is full, that's it. We're full. But if you're a regular subscriber, then you have a good chance of getting one of these promotional inspections. So send me an email, and until that promotion schedule is full, we'll give you a free 30-point DevOps inspection that we normally charge $5,000 for as a special promotion between now and Christmas. So I'll be looking out for those emails. And now back to the show. That actually makes a lot of sense. Let me try to repeat back just to make sure that I got it right. And it seems like the component is the lowest level of processing. It runs in a particular process in a memory space. It's the code that's running something, right?
Yeah. So the component is the part that really where the developer states how their code is supposed to run. So if I were to break
a Windows
this down,
service, a backend Windows service would be a component. A web application would be a component.
Exactly.
Okay.
Exactly.
Because I think people can identify, or they're used to the world where, okay, I've got a web application and maybe it's sharded and composed of 10, or maybe it's just a monolith, but I need to run 10 instances of it in a web farm. And then I've got 25 Windows services that all do stuff.
Yeah.
So each of those individual running processes is a component here.
Yeah, exactly. So that's you pretty much got it right on. That's pretty much a component. It's really, my web service, and I've created a component for it. Now go ahead and run it on-prem with 10 replicas if you want, but then on the cloud, you want to run it with, let's say, 3, because you can scale on demand whenever you want. Okay.
So the traits is the trait where, let's say I'm running what would be a Windows service, but I'm running it. The assumption is I'm running the process in a container, right? That's a big assumption.
Today, that's the execution intent that we support is containers, but we've not limited ourselves to it. But yes, yeah.
Okay, yeah. Looking forward, you're assuming that, hey, whether it's on a Windows server or whether it's Azure Container Instance, either way, it's in a container. And so the trait then is if I have what would be a Windows service, but then I run this process, a component in a container, it's running somewhere. A trait would be how many instances, whether I want just a single instance or maybe 10 instances running parallel, all watching the same queue.
Yeah, that's you got it right on. Essentially, the trait allows the application operator to take these components and say, hey, on this infrastructure, we support a maximum of X number of replicas. So apply this manual scalar trait and make sure that the Windows service only runs with, 3 replicas because we're limited to that many machines. But in the cloud, apply this autoscaler trait. And the autoscaler trait allows you to scale theoretically infinitely based on some sort of CPU and memory usage.
Right. And you mentioned in the application scope this concept of health.
Yeah.
In my experience, that's been a question that has been hard for the industry to answer. Just at any time, okay, I have all these different components, these processes that are running around. Are they all healthy?
Yeah.
And how do I know?
Yeah.
And we don't have a unit. That problem's still not solved yet.
Right.
Is this aimed at solving, you think that this solves that problem or maybe just chips away at it?
Yeah, I think this is definitely a stab at, solving that problem. The idea is simply that when you have a bunch of microservices and they are all dependent on each other, sometimes like teams are going to update just an individual microservice. And this can cause the overall app that they maybe don't have the visibility for to break. So the health scope is really allowing the operator to say, hey, all of these microservices, whether they like it or not, they kind of depend on each other. So if one of them breaks, there should be a way for me to, know that this thing is broken and I should get an alert for it. So it's really, in my opinion, a great way for, this spec to say, hey, we're kind of tackling this problem of how do you monitor the health of a bunch of microservices?
Mm-hmm. Yeah. And the old style of monitoring, whether it's a API or is are you running? Yep. Is your process on? But that just scratches the surface. The process could be running, but it could be a zombie process or maybe something works, but when you call that function that causes it to call out to something else or call out to the database, it fails spectacularly, and you realize, it was kind of down because the dependency was down.
Yeah, exactly.
So it's almost like we need some type of crawling mechanism where if you have a dependency tree and you call the top one and ask, are you healthy? It kind of needs to crawl and ask all of its dependencies, are you healthy?
Exactly. So essentially, I mean, with the health scope, what we're saying is we're offering 2 probes. Obviously, the one that you mentioned, which is that this thing starts successfully, and then we have another probe which pings a certain endpoint to get the health state of a particular service. And anytime you change anything that's part of a health scope, we're going to call that liveness probe on for all the microservices. That's essentially the hierarchy model that you mentioned, and make sure that it's healthy. But of course, it's up to the implementations to do this. The spec, again, I just want to reiterate that the spec is just a description, but then the implementations actually need to go and make sure that they're following the spec.
Well, right, and that may be some time to come, but just even talking through this problem space, like you're working with lots of big customers that have intense software environments, and these are systemic challenges. Yeah, and just talking through the nature of the solution, I think I could see individual projects happening today where they realize, oh, yes, okay, I can just implement a pattern right now, even without waiting for a .NET spec or a .NET implementation. Just that concept of call the top level, are you healthy, and have some mechanism to crawl the dependency tree so that when you get back the answer yes, it's the truth.
Exactly. Yeah. So it's really just, there needs a way for you to trust the yes that comes back. And the health scope is the thing that says, hey, when we're reporting yes, we mean truly that not only was this thing healthy, but all the things that you told us that were dependent on it or it's dependent on, like, is healthy.
Right. And when we talk about cloud native, and tell me if this was part of the conversations. I
Yeah.
think one of the assumptions is that we are going to create and configure the infrastructure automatically from scripts, and we are going to deploy every piece of the application automatically from scripts. Right?
Yep.
So in that world, well, in the manual world, when we're manually configuring servers and then we're manually deploying, copying files for code and starting it up, I guess we're used to manually checking all these things to make sure that every component is healthy, and we do it manually before we report back, okay, good job, team, we're deployed. It might have taken all night, but we're deployed.
Right. Yeah. And I mean, one of the challenges with that is just, if you just think about the burden on the operations team in order to actually set that up, the handoff between the developers and the operations to go ahead and deploy things. And if the devs ever need to get their hands dirty, it gets really dirty, and they need to understand the actual infrastructure. So it's pretty challenging.
Oh, of course it is. Of course it is. But this is a huge shift in our industry. We're going from the assumption that a human is looking at every one of these details to scripts that are doing all of this. We're kind of creating this automated robotic deployment factory where now we're realizing all of the tasks that we kind of did as humans without really thinking. We thought we had a documented process, but we only scratched the surface on all the stuff that we were actually doing.
Yeah, it's kind of crazy when you start to actually talk to a lot of customers and figure out what you need to put into like a serverless app model and implementation. You start to figure out that there's a lot of hacks and manual things people have done that it's just really hard to automate. So I completely agree with you. It's a challenge, and you're never going to create a catch-all where it's like. And that's kind of the reason where we didn't want to create like an application where we're like, here's an application and this is how you define an app, because there's no way that every person that looks at it goes, yeah, that's exactly how I'm defining my apps.
Right. But I'm thinking, and I tend to brainstorm here. I'm just thinking, you tell me if this is in line with the spec or not. If there's an Azure DevOps pipeline and there's an application that's being deployed, perhaps a partial implementation would just be a pipeline step that is meant to be a health check. And you've got to fill in the blank for whatever command or PowerShell line to call as the implementation of the health check. But the pipeline could have that concept of, hey, now we're going to do the health check on the component that we just deployed because we expect it to have come online and now be healthy.
Yeah, it's definitely a partial implementation. Is even if you took what we have today on the implementation that exposes you to the orchestration, if you just created like an automatic like a release task in Azure DevOps that deployed things and then monitored the health scope, then you're on your way to automating a lot of the manual tasks that you had to do in order to check if every single thing was healthy.
And you're right, that's a new concept that doesn't exist right now in the way we develop or deploy software, is the grouping multiple processes, multiple components together and say, okay, if one of these reports back that it's not healthy, then this grouping is not healthy. And I think that's the scope.
Yeah, that's definitely the scope. And also, and this is up to the implementations, but ideally there'd be some sort of rollback mechanism where if the upgrade actually fails, then you could just roll it back to the previous stable version. And I think that's a really key part in order to like finish the story, which is, hey, it's not just about identifying the error, but it's actually, can the platforms actually support the automatic rollback of the deployment that created the error? And that's kind of the world where we want to head to. And
yeah, well, so your team is coming from all of the work done on Azure Service Fabric.
Yeah,
and so what are some? We've heard that so many of the big products now in Microsoft are kind of running on top of Azure Service Fabric as the base level of infrastructure. Are there any other like big lessons or big solutions that kind of aren't acted upon yet, but are in the conversations that, hey, we need to figure out how to bring this learning to the customers?
Yeah, so the big one for sure is, if you looked at what Service Fabric really started off as, it started from SQL and from the migration that we as Microsoft wanted to do from taking SQL on premise to the cloud, and we really wanted to build a cloud native SQL. So Service Fabric was built with state in mind always. So if you looked at our website or if you looked at what we had, we really wanted to push stateful programming models and make sure that it's easy for you to build stateful programming models in a cloud native manner. And I think this is one thing that is kind of forgotten, where we've kind of landed on this world of 12-factor stateless applications. But there are just some applications, and especially if you're having things like sticky sessions or anything like that, where you need some sort of statefulness. So that's a learning from Service Fabric that it's on our roadmap, but we haven't really brought it to the specification right now. But just because, SF is so mature with state, and we released Dapper, which is really good at, abstracting away the state and making it easy for developers to access their state providers. It's definitely something that is on the roadmap, is how do we kind of take Dapper and Ohm and how do we bring them together? Any ideas, for any of the listeners, if you have any ideas, we're actually actively looking and trying to figure out how we can marry these two projects.
Okay. Awesome. Well, this is, I think, the first two guests that we've had directly from the distributed systems platform team, which I think just came about in the last few years at Microsoft as an actual organization.
Yeah. So probably a few years before I joined is when it started. You must have talked to probably Mark in the previous podcast. Yep. And yeah, he led the Service Fabric initiative for a long time before he started working on Dapper. So you can see a ton of the inspirations in both places, both in Dapper and the open app model.
Right. Well, these are tough problems, and as software systems become two things. One, both less monolithic, where they're deployed as more processes from a runtime perspective, and then also when we move to the cloud native model, which I think really from a layman's perspective, it's defined as we assume that we're going to configure and provision all the infrastructure automatically, and we assume that we're going to deploy every piece automatically. Those two things are the big shoot. They change the whole way of working from a development perspective and what we assume, what we plan for. So it's an exciting time.
Yeah, really at the end of the day, what we're looking to do is improve organizational efficiencies, whether it comes to developers making sure that they can focus on their code, and operations to have an easy time actually managing the applications. And both of these projects, one of them, Dapper, is targeted straight at the developer who's writing code. And when you're writing cloud native apps, you shouldn't need to think about, what we're saying is you should need to think about all the dependencies, how things are set up. And when you're looking at kind of the deployment and the operations side with the open app model, you shouldn't care about the infrastructure. In a cloud native world, the cloud should manage the infrastructure for you, and you reach your highest efficiency when you can just deploy and manage these apps without worrying about the cert provider or how autoscaling is done, how many nodes are there, what's the skew of the nodes. So yeah, it's really exciting times with both of these projects, and it's getting a lot of traction in the ecosystem, and we're getting a lot of community feedback on both of these projects, so it's good times.
All right. Well, we mentioned quite a number of resources and URLs, but for people who are really motivated to kind of dig in right away, are there any other resources that you would point them to?
Yeah, absolutely. So a couple of really good resources are, one, if you go to the 2019 MS Ignite sessions, there are two sessions by Mark Russinovich that are really good. One of them is the Microsoft Mechanics show, where he gets hands-on with both the Dapper and the open app model. And he has another deep dive session if you really want to understand everything about traits and scopes and actually look at what the specification looks like and what the implementation looks like. That's a 75-minute session that he does, which is really good. And then, of course, you have the GitHub repositories. So if you go to www.github.com/ohm-dev, you'll see the entire Ohm GitHub organization, where we have the spec repos and all the implementations.
Okay, that's /OAM-DEV.
Yes.
Right. Awesome. And you mentioned Ignite. I just want to give the URL to listeners. That's aka.ms/msignite on demand.
Yeah.
And all the sessions are searchable. I had the privilege of being on staff at Ignite this year as a part of the community reporter team.
Oh, nice.
And yeah, I was pretty impressed at how I was working inside the embedded television station, like literally with the director and 4 producers and everything.
Yeah.
Control room.
Ignite's a real show. I mean, it's just crazy how vast the show is. I mean, I was there for the whole 5 days, and I was at the expo hall and talks most of the days. But yeah, there's a ton of recordings and mechanic shows that happen. So hope you had a good time there.
Yeah, it was fantastic. And I see you've gotten your voice back.
Yes. Yeah. I actually, right after Ignite, I went to KubeCon for another 5 days.
Oh, gosh.
So it was 2 straight weeks of conferences for me. And if we had this podcast, the day after KubeCon, which was last Friday, I had no voice. So
yes, I believe it.
It's a good thing I had a little bit of break.
All right. Well, hey, thank you so much for taking some time out of your busy schedule and visiting with us. This is some great information. Appreciate it.
Absolutely. Anytime.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.